Welcome to Math 10C. We are in Chapter 7, and specifically in Lesson 7.5, which looks at a new strategy for solving a system of linear equations algebraically. Hopefully you all remember at this point what a system of linear equations is. It's when we have a set of two or more linear equations. Remember, linear equations, each variable has an exponent of 1. The solution of any equation is the value of the variable that makes the equation true. And the solution for a system of linear equations is the ordered pair that makes both equations true. So each line has an infinite number of points on it. But if two lines intersect, there's one point that lies on both lines, and so that is the solution to the system of linear equations. And that's what this final point here says. Graphically, the solution is the point where two lines intersect. All right. With that reminder, I would like you to take a look at these warm-up questions in the notes. So on this page, you will see that there are 5 warm-up questions. So at this point, please pause the video. And once you have completed as much as you're able of these 5, restart the video, and you'll see my solutions. You can pause now. Question number 1, hopefully is pretty straightforward for you. We're just looking for the like terms. So the x's can be combined to give us 5x, and the y's can be combined to give us 3y. And that's it for number 1. Number 2, similar, but with subtraction, it can be easier to make mistakes. So what I've done to begin with is I've distributed the negative sign into the second bracket. So that's what we get, how we get the red expression at the top. And then I've rearranged it to group the like terms together. So we have our x terms together, and we have our y terms together. Simplify it to get an answer of x plus y. Also, that should be pretty straightforward. That's from previous grades. Now, question number 3, I'm guessing that some of you, as you completed this question, you actually solved for x to get x equal to 23, and then just multiplied by 5. But what I want you to notice here is that if I look at the left side of my equations, this 3x and the 2x, if I were to add those together, that would give me 5x. So if I add the 2x to this 3x, there I get the 5x. If I do that on the left side of the equation, then I'll also need to do it on the right side of the equation. And so I will add the 69 and the 46, and that will give me 115, if I did my math correctly. Okay, so that's a little bit different than what you may have done, but we can use a similar idea for question number 4. Because again, as you look at the two x's that we have, the 3x and the 2x, if I add them together, I'll get the 5x. And if I look at the 2y and the y, add them together, that'll give me 3y. So I could look at my first equation, 3x plus 2y equals 7. And my second equation, 2x plus y is equal to 2. If I add my x's together, I'll get 5x. Add my y's together, I get 3y. And then I'll have to add together the right side of the equation to get 9. There we go. 5x plus 3y is equal to 9. That may suggest a strategy for number 5. For number 5, I start with the 3x in the first equation. I have a 2x in the second equation. I want just an x. So what if I were to subtract the two equations? So there you can see my first equation subtracting the second equation. means that on the right-hand side, I'll need to do the 7 subtract 2 to give me 5. So x plus y will equal 5. So this is showing us that if I have two equations, I can add the left sides together, the right sides together, and get an equation that will also be true for the same values of x and y. That is the key idea behind this strategy of elimination. In the box on the right, you'll see steps that we'll go through as we solve this equation by elimination. First step is multiply or divide both equations by a constant to get matching coefficients. So I didn't say equal coefficients because they don't have to have the same sign. We don't want to have the same size of number in front of one of the coefficients. And so as you look at this set of equations, both of them have a coefficient of 1 or negative 1 in front of the b. That's what we're looking for in step 1. So once we have that, our goal will be to eliminate that b variable by adding or subtracting the two equations together. Since they have opposite signs here, we will add the two equations. So from the first equation, the a plus 2a will give me 3a. The negative b plus b will give me 0b, so I'm not even going to write it down. And then 7 plus negative 10 is negative 3. And by doing this, I've come up with a simpler equation with just one variable in it. So now I can solve for a. Dividing both sides by 3, we get that a is equal to negative 1. And that quickly, we found one of the coordinates for our intersection point of these two lines. Once we have this, we can choose either equation. So I'm going to label the equations. I'll call the first equation number 1. The second equation I'll call number 2. And I can pick either one to substitute this a value into. So why don't I pick equation 1? I know the a, and then I'm going to subtract b, and it has to equal 7. So I'll substitute negative 1 in place of a. In order to solve this, I'll want to add 1 to both sides of the equation. Then the negative 1, positive 1 cancel out, and notice this negative sign in front of the b that was subtraction now becomes a coefficient of negative 1 in front of the b. So negative b is equal to 8, and then we could multiply both sides by negative 1, or divide them both by negative 1 to get b is equal to negative 8. And there we have an ordered pair solution for this system of equations. Looking back at the procedure in the boxes on the right, we had the matching coefficients at the beginning, and so we added our equations in order to eliminate one of the variables. Then we went through and we solved for the remaining variable and got a equaling negative 1. And then we substituted that value into equation 1 to solve and get our second variable. Now we have one step to go, and that is to verify our solution. If we have the time, it's ideal for us to plug this AB ordered pair into both equations, but at bare minimum, we want to use the equation that we didn't use in our previous step. So we just used equation 1, so now I'm going to use equation 2, which was 2a plus b equals negative 10. And I'll substitute negative 1 for a, negative 8 for b, and then simplify both sides. Negative 2 minus 8, is that negative 10? And yes, it is. Which confirms that I have solved this system. If we wanted to write the solution as an ordered pair, we don't have an x and y. So typically what we will do in this situation is we'll put the variables in alphabetical order. So the a first, negative 1, and then the b, which is negative 8. If you have any questions about that, you can pause the video here and review the steps in that process. But for the rest of us, we will continue on to question number 7. As we look at number 7, we don't have matching coefficients with the x or with the y to begin with. So we need to do a bit of work. As we look at the two variables, it looks like it's going to be easiest to get matching coefficients for the y variables. So I'll label my equations 1 and 2, and then I'm going to take equation 1 and I'm going to multiply both sides by 2. When I do that, I'll get 4x plus 2y equals 4. And now I have a coefficient of 2 in front of my y, which matches my second equation. So I'll rewrite that equation. And now I can add or subtract. So my goal is to eliminate the variable. Since both coefficients have the same sign in front, subtraction will be my best choice, really the only choice, if I want to eliminate the y's. So 4x minus 3x gives me x, 2y minus 2y gives me 0 y's, and 4 minus 7 gives me negative 3. There is the x coordinate for my solution. Then we'll choose one of the equations. I've chosen equation 1, and I went back to the original equation rather than the modified equation. It wouldn't matter, but if you have the option and the original equation isn't too complex, good idea to go back and use that one. Substitute the value for x, and then we'll go through the steps to solve for the y. And we get y is equal to 8. Since we just used equation 1 to solve for our second variable, when we verify, we're going to go to equation 2 and substitute the negative 3 for x, positive 8 for y, and we'll see that the left side equals the right side, and so we have a solution to this system of linear equations. X is negative 3 and y is 8. All right. Again, if that was too quick, feel free to pause, go back and replay what you need to. Question number 8 is check your understanding. So at this point, I would like you to pause the video, try this question, solving by elimination. And once you're done this question, then you can restart the video to see my solution, and we'll go on to the next example. All right, here you can see the first few steps. I've labeled my equations 1 and 2 just to help me be organized. I chose to multiply the first equation by 2. I could have multiplied by 3 if I wanted to get the y's matching, but I chose to get x's matching. And so what I did was I looked at these two equations that I have boxed off here. Those are the two equations that I ended up subtracting in order to eliminate the x's. So the 8x minus 8x gave me 0 x's, and then the negative 9 minus 6, so remember we're subtracting, that gave me negative 15y. On the right-hand side, I have 15 minus the 30 to give me negative 15. One comment I should make at this point is when we multiply an equation by a number in order to get matching coefficients, the easiest mistake to make is to forget to multiply the right side of the equation by whatever we multiply the left side by. So we often remember to multiply the variables, but then we forget to do that for the constant on the right. So we found the y coordinate. Pick an equation. I choose equation 1, substitute the y and solve for x, and then verify in equation 2, substituting both x and y, And if I wasn't getting left side equals right side, I would double check to make sure I did my verifying correct first. If I'm confident that was correct, then I need to go back and check my algebraic process for solving to find y and then x. All right, on to question number 9. This time we have fractions in our coefficients. And while I say fractions are your friends, sometimes you can get tired of your friends and you want them to go home. So getting rid of the fractions is the most common way to do these questions. If you're really comfortable with fractions, you can see that we could just multiply our second equation by 2, and then I would get a 2/3 x, which would match my first equation. So if you're comfortable with that, you're welcome to do it, but that's not how I'm going to do the question. Instead, what I'll do is I will look at my first equation and say, well, what do I need to multiply both sides of the equation by in order to eliminate all the denominators? So I'm looking for what is the lowest common denominator or the least common multiple of those denominators. And as you look at that, if you imagine that would be 15, you would be correct. So I will multiply each term by 15. When I do that, 15 divided by 3 gives me 5. And so I'm going to get 5 times 2, which is 10x. And then 15 divided by 5 is 3. 3 times 1 is 3, so I'll have 3y. And then on the right-hand side, we'll have negative 30. So we have an equation with the same relationship between x and y. So it's exactly the same line if we were to graph it. But we don't have fractional coefficients. For the second equation, take a moment to think about what's the lowest common denominator, and then pause the video and multiply both sides of the equation by that common denominator to eliminate the denominators. You can pause the video now. All right. Here's my second equation. And hopefully you multiplied each term by 6. And when you multiplied by 6 and then simplified, you will have ended up with the equation 2x minus 3y equals negative 42. So fractions are gone. Now we can look at our two equations, and we can see that we have matching coefficients already. We have a negative 3y and a positive 3y. So we can add the two equations together to solve. So again, you're familiar with what to do from here, so pause the video. When you finish the question, including verifying the answer, restart the video to have a look at my solution. So you can see here what happened when I added my two equations together and then solved for x to get x is equal to negative 6. Choose one of the equations, and I went back to the original equation with fractions in it. And in that equation, I substitute the negative 6 in for the x. And simplifying, that'll give us negative 2 minus y divided by 2 equals negative 7. We'll add 2 to both sides of the equation. and then multiply both sides by -2 to solve and get our y value of 10. We have x and y. We can verify. Again, notice that I alternated equations. I used equation 2 in blue on the right, and then I used equation 1 to verify. And the solution, x is -6, y is 10. Let's look at the next question. So this question doesn't have fractions, but it does have decimals. Again, we could work with decimals, but often what we'll do is we will multiply the equation that has decimals by some power of 10 in order to get rid of the decimals. Since each of these is to the nearest tenth, then we can multiply both sides by 10. That gets rid of our decimals and gives us the equation 7r plus 6t equals -11. But now as we look at the variables, we don't see an easy coefficient to match. So it's our choice. What we need to do is we're going to have to multiply both equations by something in order to get matching coefficients. So what I'm going to do is I'm going to take equation 1 and I'm going to multiply both sides of the equation by 7. That'll give me a 21r. And when I take equation 2 and multiply it by 3, that'll also give me a 21r. So there we have the matching coefficients. A little more work because I had to modify both equations. But once we do that carefully, making sure we multiply both sides of the equation, then we can subtract the two equations, which eliminates the r, and we can solve for t. And we get t is equal to 1/2. Then we can choose an equation to substitute that into. And here I've picked equation 1. Substitute the 1/2 in and go through and solve for r. And then I can look at equation 2 to verify and see that left side equals right side. Again, notice when I verify, I go back to the original equation that I had. Probably a good idea to pause here to make sure you get all the details written down. And once you have that, then go on to the check your understanding question. And once you're finished with that one, you can restart the video. If you haven't completed question 11 yet, then you should, again, pause the video, work through 11, 12, and 13 as well. So the rest of this lesson is check your understanding, complete them all, and then restart the video. As you look at my work here, you can see that I got rid of the fractions, multiplying the first equation by 4, the second equation by 8. Then I was not far from matching coefficients. I chose to get y's with matching coefficients. So I took the second equation and I multiplied that second equation by 2. Then I was able to eliminate the y's by adding the two equations together to solve and get x is equal to 48. Let's do this first. Continuing on, I substituted that into equation 1, solved for y, got 36, and then verified in equation 2, ending up with the solution. X is 48, y is 36. Feel free to pause and go back and check over any of this work as you need. And if not, we are on to the next page and the final set of questions. As you look at my work so far for equation 1, I'm guessing that you probably didn't do what I did. So what I had suggested previously is that where we have decimals, we can multiply, in this case, both equations by 10. But as I looked at these, I thought, you know what? I could divide and actually simplify the equation and get rid of my decimals right away as well. So I chose to divide equation 1 by 0.2, giving me 4m plus 9n is equal to 1. And I did something similar with equation 2, dividing both sides of the equation by 0.3, and that eliminated the variables. So with elimination, this process, we can multiply one equation or both by a value in order to get matching coefficients, but we can also divide one equation or both by whatever number works well in order to get matching coefficients. So here I don't have matching coefficients yet, but I'm close. And I did get rid of the decimals as I got to this point. So let me finish off the question with you. To get the matching coefficients, I multiplied the second equation by 2, was able to subtract and eliminate the m's. Then once I solved to get n is equal to -1, and when we solve this equation, after substituting the n value, we get m is equal to 2.5. And then I can verify using the other equation, and shows up that it works. So there's my solution, again in alphabetical order. My ordered pair is 2.5, -1. Final question. This one also is a little bit odd. As you work through, you might have gotten to a place similar to what I did, which when I got matching coefficients and then added my equations together, all of the variables canceled out and I got 0 equals 27. So that leads to the question, well, what ordered pair can make this true? What values for x and y can make 0 equal 27? Well, that's kind of a ridiculous question because 0 can never equal 27, which means there is no solution to this system of linear equations. This is not something we've seen before, but sometimes this happens. If we were to look at the graphs of these two equations, what we would discover, here I've entered them just as they are into Desmos, and you look at the lines and you see they're parallel. And parallel lines never intersect, and so there's no solution to this system. There we go. That is the end of this lesson. Make sure you do some practice questions. If you have checked your understanding handouts, that's great. Or you can use the textbook to work on one of these sets of questions as well. All right, have a good day.